multiply the numbers that are across from each other and divide by the third number. That's exactly right. It's just what you do anyway. You're just not showing the steps. You're exactly right. Similar polygons are proportional. Similar polygons. Let me explain what similar polygons are. Two shapes that look identical, but they might be different sizes. They're not congruent, because congruent would mean they're the exact same size. That's two words that we've got to be careful of using. Congruent and similar. Congruent, same size, same shape. Similar, different size, possibly same shape. Okay, look at this. Find the missing sides of the similar figures. They are similar because they're the same shape. Identical shapes, just one of them. The way that I drew this is on paint. I drew this first triangle, then I took and stretched it out. That's what similar shapes are. One of them is just a kind of a blown up version. If you put it on a copy machine and you hit times at 200% and blow it up, those are similar shapes. So if these are similar, this is the first thing you need to know. It says triangle MNO is similar. That little squiggly mean is similar to triangle UVW. What that means is M is similar to U. M and U kind of go together. They're the same angles. Okay, and they will be the same angles. Even though they're different sizes, the angles are still going to be the same. N and V are going to be the same angle. So let's talk about correspondence. If I, from here on out, say, okay, what corresponds with 16 on our second triangle? Y'all try to wake up, Grant. Guys, y'all raise your heads up, please. Raise your head up and listen. 16 goes with 24. Does everybody understand that? What goes this 16 go with? The other 24. What does this 14 go with? X. Yes, it is. Sure did. Similar shapes are proportional. I told you 16 goes with what? 16 goes with 24 equals, we want to find this X though. Look how I got that. Those are proportions, right? 16 went with 24, 14 went with X. Write it as 16 goes with 24 equals 14 goes with X. Solve it just like you did all these other problems. You sure could. Let's do it backwards. You could have done X goes with 14, and you'd have to do then 24 goes with 16. If you're going to do the first shape goes with the second shape, then in your second proportion you've got to do first shape goes with second shape. No. Oh, now hang on. You have to match them up to where, okay, this side looks like this side, they go together. Yes. So this MN side has to match up with the UV side. And let me show you this statement they give you down at the bottom, how you can tell by looking at this which sides go together. What's the first two letters? What's the first two letters over here? They go together. MN and UV match up with each other, which you could tell just by looking up here, but some shapes you can't. Side NO goes with VW. Okay, those match up. And finally, MO goes with UW. That's how you can tell what sides go together. Yes, sir. Yes. 16 over 24 equals 14 over X. Is that right? No, you cannot, because again, let's talk about why. It all depends on what went together. 16 went with, look at your second shape, 24. That's the reason you did 16. Now, I see what you're saying, and I'll address that in a second. 16 went with 24, 14 went with X. Okay, he's wanting to know, can I put X on top if you want to? Let's do X over 14. Then you'll have to do 24 because it's the first or second shape over the first shape equals the second shape over the first shape. If you're going to do X over 14, you're going to have to do 24 over 16. So there's tons of different ways. I think there's like four ways you can set this problem up right. But the problem is, there's 4 different ways you can set it up wrong too. So just make sure if you're going to do X over 14, you do 24 over 16. If you're going to do 14 over X, you're going to do 16 over 24. Okay? And then back and let's actually solve the problem. Let's use our shortcut. 24 and 14 multiplied is 336. Divided by 16 is 21. So X must be 21. It's not hard, right? And yeah, that's it. And do you see that it kind of goes together? 16 and 16, and then this side's a little bit smaller. 24 and 24, and this side 21 is a little bit smaller. Example 6. We're nearly finished, guys. 2 more examples. To keep a proper balance between fish species A and species B in an experimental fish pond, a wildlife biologist needs to keep the ratio of species at 2 to 3. They want to keep the ratio always 2 to 3. So you got this ratio 2 to 3. Write and solve the proportion to find how many of... Now, this is the ratio of species A to species B. So which one's A and which one's B? That's it. Does it say fist? Oh, my bad. Again, they want to keep it balanced. They want to keep always the ratio 2 to 3. Does that mean, because I addressed the same thing with my pre-calculus Sherstein, does that mean that there's going to be 2 always? Does that mean there's going to be 2 of fish A and 3 of fish B? No. The ratio is 2 to 3. Could I have 4 of fish A and 6 of fish B? Yeah, because what's that ratio? Reduce that. 2, 3, right? Could I have, what's another ratio? What's another amount of fish I could have? I could have 8 and 12. How did you get that? You multiply top and bottom by 4. So you could have 8 of fish A and 12 of fish B, right? You could have 6 of A and 9 of B. You could have, what'd you say? 16 of A, 24 of B. But it says, write and solve proportion to find out how many of fish of species B. So we don't know how many of B, but we do know that there's 256 of A. So what about this? Is our answer going to be bigger or smaller than 256? Bigger, because we want it 2 to 3. There's always going to be more fish B. So just solve that proportion now. You do the numbers that are across from each other, which are 3 times 256, 768. Divided by what? Which is equal to 384 of fish B. Any questions? Y'all handle that? Last problem. Example 7 says, suppose that a 6-foot tall person casts a shadow that is 10 feet long. 6 foot tall, shadow's 10 foot long. A nearby statue casts a shadow that is 16 foot long. Let me explain how you can actually use this. Trees out in your yard. Let's say that there is a 50-foot tree in your yard. Would you like to take a tape measure and climb to the top of that thing to find out how tall it is? No. You can use this method for finding out how tall things are. Please. It's called indirect measure. Okay, you don't, just to find out how tall something is, you don't have to take a tape measure and measure it. You can measure it indirectly. We're not going to measure this statue. We measured its shadow, and that's all we're going to need to find out how tall it is. Somebody that's 6 foot tall, their shadow is how long? 6 foot tall, 10 foot long. How tall is the shadow? Or how tall is the statue? Is it? A nearby statue casts a shadow. We don't know how tall the statue is. X, we know that its shadow is 16. What's that? 6 over 10? Now, the inches, like 10, you could change 10 feet to inches. 6 foot is equal to 72 inches, because 12 inches in a foot. So here we go. Everybody understand, because the important part of this is how to set it up. Somebody's 6 foot, shadow's 10 foot long. We don't know how tall the statue is, but we know its shadow is 16 foot long, so we're going to do 6 times 16, and then we're going to divide it by 10, which you get 9.6. Without having to measure the shadow, or without having to measure the statue, we know that it's 9.6 feet tall because of its shadow length. Any questions?